So we are on day 2 of polynomial functions of higher degree with modeling. All right, we're going to start off talking about multiplicities of a zero of a polynomial function. Okay, if f is a polynomial function and x minus c to the m is a factor of f, but x minus c to the m plus 1 is not, then c is a zero of multiplicity m of f. Zeros of odd and even multiplicity. If a polynomial function f has a real zero c of odd multiplicity, then the graph of f crosses the x-axis at c, 0, and the value of f changes sign at x equals c. In other words, the function value changes. If a polynomial function f has a real zero c of even multiplicity, then the graph of f does not cross the x-axis at c0, and the value c does not change sign at x equals c. Now, what the heck does all of this say? Well, let's say that if I had a polynomial, or a function, and it's in factored form. Like, let's say I have x minus 3 to the third times x plus 7, I don't want that big, x plus 1 to the second, let's make it to the fourth, times 2x. Okay? What this tells me is that, remember, if I just had the function x minus 3 times x plus 1 times 2x equals 0, we could use the zero product property and said, well, then either x minus 3 is 0, or x plus 1 is 0, or 2x is 0. In this case, x is 3. In this case, x is negative 1. And in this case, divide by 2, x is 0. Which meant that this thing would cross the x-axis at 3, negative 1, and 0. Well, it's exactly the same thing, except for now you have powers. Okay? This x minus 3 was to the third. This x plus 1 was to the fourth. And this 2x is to the 1. This power is odd. This one is even. And this one is odd. And what this says is, on a graph, excuse me, this thing will cross at negative 1. Actually, it will not cross because this is an even power. So what it's going to do is, okay, hold on, we got to back up to our leading test degree. If I multiplied my first terms only, I'd have x cubed times x to the fourth times 2x, which is going to be 2x to the 8th. Okay, which means tails are going to be the same tails, and positive means both up. So at negative 1 here, this tail has to be pointing up. But when it reaches this negative 1, it's not going to cross through. It's just going to touch it and turn. And then, I don't know, it's going to wiggle in the middle till it gets to the next 0, which is 0. All right? Sorry, I didn't have much wiggling in the middle there. Okay? At 0, I don't know what it does, but at 0, it's going to come back and it's either going to pass through it or it's just going to touch and turn. Its degree is odd, and odd means it will cross. So it's going to come back down at some point and cross through 0 and head to the last one, which is at positive 3. At positive 3, it's either going to pass through or it's going to touch and turn. Okay, it'll either go through or it will touch and turn. Look at the degree. Its degree was 3. 3 is odd, means it passes through. Okay, so there would be a rough sketch of, now again, I don't know about these wiggles in the middle, how high, how low, but I know that at negative 1 it will it won't pass through, it will just be what we call tangent. At 0 it will pass through, and at 3 it will pass through. Passing through because it had an odd degree. Tangent because it has an even degree. Passing through because it has an odd degree. Okay, so it says sketch the degree and list the zeros of the polynomial function. State the multiplicity of each zero and whether the graph crosses the x-axis at the corresponding x-intercept. Then sketch the graph of the polynomial function by hand. Okay, so the first thing we need to do is we need the degree and list the zeros of the polynomial. Well, again, to get the whole degree, I need to look at just multiplying my x's together in each of the factors. So I would have a negative x cubed times an x to the fourth. Again, x's in each factor, and that would give me altogether a negative 1x to the 8th. Okay, so even degree tells me same tails, and negative means they're both going to point down. Now, where are they going to cross through the x-axis? You take each of your factors, okay, negative x cubed, set it to 0, solve it, divide by negative, x cubed equals 0, cube root, x equals 0, with a multiplicity 3. Okay, then we're going to take my next factor, x minus 2, set it to 0, and solve, add 2, I get x equals 2, multiplicity 1. Okay, and then I'm going to take my last one, x plus 3 to the 4th, and set it to 0. You take the fourth root, you get x plus 3 equals 0. Minus 3, x equals negative 3, multiplicity 4. Okay, you see where I'm getting the multiplicity. Multiplicity of 3 because it had a degree 3. This is multiplicity 1 because the degree was 1. This is multiplicity 4 because the degree was 4. Okay, now what does that mean for my graph? Sorry, you weren't supposed to see that yet. For my graph, I know that my tail has to point down. Hold on just a second. Okay, so if I were to graph this, I know that my tails have to point down. Okay, I'm going to have an intercept at 0, at 2, and at negative 3. Okay, so the tail is going to come down here this way, and on this side it's going to be pointing down. Now it's going to hit each of those zeros and either pass through or touch and turn, and then it's going to wiggle in the middle. I don't know exactly how. So the first one I'm approaching is the negative 3. Because it has an even multiplicity, it's just going to touch and turn. Get it? TNT? Even TNT. So it's going to come up to the negative 3, but instead of passing through, it's just going to touch and turn. And again, I don't really know what's going to happen here in the middle, but eventually it's going to head to my next 0, which was 0. It has an odd multiplicity, which means it's going to pass through, PT. So it's going to pass through, wiggle in the middle. I don't know what it's going to do, but it's going to eventually head back to this 0. And it's either going to pass through or it's going to touch and turn. If I look at what happens at 2, it's got a multiplicity 1, which is odd, which means it's going to pass through. Okay. And if I type it on my graphing calculator, I can see that it comes up to negative 3, touches and turns, comes back, passes through at 0, comes up and comes back through at 2. Okay, so if we do this one the same way, to get my degree and my tails, I need the first term. So if I take my 7 times an x squared times an x to the 4th, I'm going to get 7x to the 6th. Okay, so since my degree is 6, that means I'm going to have same tails. Since my leading coefficient is positive, that means they're both going to point up. Where's they're going to cross my x-axis? You take your factors and set them to 0. This is a factor, but it's not a solvable factor because there's no x in it. So it's not going to give me an intercept. So my other factors are x minus 3 squared, set it to 0. And my x plus 5 to the 4th equal to 0. And if I solve, square root, x minus 3 equals 0, add 3, I get x equals 3. And it has multiplicity 2, which is even, which means touch and turn. Okay, so at 3, it's going to touch and turn. Okay, my next one, x plus 5 to the fourth equals 0. Take the fourth root, I get x plus 5 equals 0, minus 5, I get x equals negative 5. Multiplicity 4, which is even, which means it's going to touch and turn. So over here at negative 5, it's going to touch and turn there as well. And my tails have to both point up. Okay, so touch and turn, it's going to wiggle in the middle. At some point it's going to hit this one, touch and turn, and it's going to head back up. Okay, if I confirm that, I had to change to get a pretty accurate picture. I changed my window pretty drastically because I couldn't see what was happening in the middle, but you can see it's tangent there and it's tangent over here at negative 5. Okay, like I said, to get a good picture of it, I had to use a pretty extreme window. Alright, so it says find the zeros of the polynomial function and state the multiplicity of each. Push pause and come back when you're ready. Okay, and hopefully you got 3. If I get my leading term, I'm going to have a negative 5x squared times an x cubed, which is going to give me a negative 5x to the 2, 3, 4, 5, 6. Okay, 6 is even, which means same tails. Leading coefficient is negative, which means both down. Okay, my zeros, set each factor to 0. Negative 5x squared equals 0, x minus 8 equals 0, x plus 3 cubed equals 0. If I solve these, divide by negative 5, divide by negative 5, x squared equals 0, square root, x equals 0, multiplicity 2, which means it's even and it's going to touch and turn. Okay, if you solve this one, add 8, I get x equals 8. It has degree 1, so its multiplicity is 1, which is odd, which means it's going to pass through. And if I solve this one, cube root, x plus 3 equals 0, minus 3, x equals negative 3. It has multiplicity 3, which is odd, which means it's going to pass through. If I was sketching this, which I didn't have to, so there's my negative 3, multiplicity 3, my 0, multiplicity 2, and my 8, multiplicity 1. But if I were going to sketch a graph of this, I know that both tails have to point down. I'm going to pass at negative 3, at 8, 1, 2, 3, 4, 5, 6, 7, 8, and at 0, and both tails have to point down. So let's see, it is going to go touch and turn, right? No, sorry. I'm reading left to right. I'm over here at negative 3, so that's going to pass through at negative 3, come back to the 0, but that's going to touch and turn. And then it's going to come up and back through, and it's going to pass through at 8. Both tails pointing down. And there's the graph if you can kind of see it. Okay, the actual graph. Alright, so you can push pause, do this, come back when you're ready. And I hope you got number 1. If you did not, let's look at y. I'm going to have an x squared times an x cubed, which is going to give me a positive x to the 5th, which means opposite tails. And since it's positive, that means second tail is up. So it's got to do this. Some wiggle in the middle. Okay? Alright, so this says, if I do my factors, x plus 2 squared equals 0, x minus 3 cubed equals 0, square root, x plus 2 equals 0, minus 2 minus 2, x equals negative 2. Multiplicity 2, which is even, so it's going to touch and turn. And you can see at negative 2, it touches and turns. So this one, cube root, I get x minus 3 equals 0, add 3, x equals 3. Multiplicity 3, which is odd, which means it's going to pass through. So it does all this wiggle in the middle, and then at 3, it actually passes through. Just like my dogs are doing. Okay, so what happens at even multiplicities of factors? The graph will touch and turn. What happens at odd multiplicities of factors? The graph will pass through. Okay. All right, the intermediate value theorem. The intermediate value theorem states that if a and b are real numbers with a less than b, and if f is continuous on the interval a to b, then f takes on every value between f of a and f of b. In other words, if y sub naught is between f of a and f of b, then y sub naught equals f of c for some number c in a comma b. In particular, if f of a and f of b have opposite signs, i.e. one is negative and the other is positive, then f of c equals 0 for some number c in the interval a to b. What does that mean? All right, if you look at this graph, okay, and they're using function notation. So if I looked at this point on the graph, this point would have, for its x coordinate, it would have a. For its y coordinate, it would have f of a. Agreed? Which is just the same as x and y. They're just using whatever, instead of calling this 5 and just picking a number, they're saying call it a. Okay, so for this point, here's b on the x-axis. The point that corresponds to that on the graph would have an x-coordinate of b and a y-coordinate of f of b. Again, it's the same as x and y, they're just using function notation. What the point is saying is, look, if f of a and f of b have opposite signs, in this, for f of a, the y-coordinate is below the x-axis, so whatever this is, it's negative. And over here, whatever this y-coordinate is, it's above the x-axis, so it's positive. And what this says is then, if this y-coordinate is negative and this one's positive, or vice versa, in other words, if there's a change in sign, then only one thing could have happened. The function had to cross the x-axis, meaning you have to have a 0 in there. You have to have a solution. You have to have an x-intercept between the interval a to b. Okay, that's what all of this mess says. All right, so it says, graph the function of viewing window that shows all of its x-intercepts and approximate all of its zeros. All right, so I typed it in, and I used this window so that I could see clearly. When I did a standard window, you could barely see this, okay? So I changed the window a little bit, and you'll get used to messing with it. Try it on your own before you, well, I guess it's a video, you're going to see it anyway, huh? Anyway, you kind of have to mess with the window to get a good picture. Sometimes whenever you look, when things look really close, like you zoom 6 it and you look like that, don't trust it. If you zoom in between these y coordinates, in other words, set your y min to whatever this is and your y max to whatever this is, zoom into there and you can see whether it actually is touching once or twice. At any rate, then you're going to calculate your zeros. I calculated this one, it was at negative 2.47. Negative 2.47. Then I calculated the next one and got negative 1.46. And then I calculated the next one and I got, and see, look how we're here. You're going, well, that isn't, because to get an x-intercept, y has to be 0. Remember, that's saying negative 1e to the negative 12th, which means the decimal has 12 places this way, which means there's 11 zeros in front of that negative 1, which means for all intents and purposes, y is 0. And I've got an x-intercept at 1.94. Okay? And then you just kind of sketch the picture. Okay, so do this one. Hit pause, come back when you're ready. And hopefully you got 4. If you did not, look at why. Move this stuff out of the way. I hit the graph and I chose this window because, again, you type it in and hit zoom 6, okay, and again, it's not going to be that clear of what's going on there. So I actually set my window to this, okay, and then I still wanted to zoom in more, so I actually, for the y's, only went from -1 to 1, and then I could see this, okay. So now, how did they get these zeros? Well, when I tried to do left bound, right bound on this one, I got error, no sign change. What that means is, but I can see that it actually touches there. What this means is it doesn't cross through, it's a tangent one, which means it has an even multiplicity. So if you notice, why are they listing this one twice? Well, if you can't do the calculate 0 because there was no sign change, but if you just use the trace function and get as close to that point as you possibly can, it's going to be pretty darn close to -3.12. Okay, so then I calculated this one, and I got, oh, sorry, I was showing you, back up. So I just used the trace function, and see how I got, it was really close to 0, y being 0 right there. I was as close as I could, I thought, by eyesight. Okay, so my left bound was, my calculus says -3.09, but in a multiple choice situation, the closest thing to that is this one. Okay, and again, they listed it twice because it's tangent there. So then I calculated the next 0, and I got that at -2.4966, whatever. They got approximately -2.51. Again, it's because who knows what these calculators are going to do, the pixels and the resolution and all of that stuff I don't understand. All right, and then the last one I calculated, sorry, I'm trying to move this, and I got -0.6299, and they got -0.63. Okay. All right, be careful on that hidden behavior. All right, try this one. Come back when you're ready. And if I do the graph, I use this window. There's only one x-intercept. If I calculate it, I got the 1.28. Okay, so what does the intermediate value theorem show us? That if you find f of a and f of b and signs are different, let's say opposite, then there must be 0 between x equals a and x equals b. Okay, if here's a and here's b, and this thing is, let's say, doing something like this, sorry, f of a would be positive, and this point corresponding to b on the x-axis would be b comma f of b, but the y value would be negative, which means that somewhere between those two numbers it had to cross the x-axis, which it did. Alright, writing a polynomial from its zeros. Write the zeros in the form x equals whatever, dot 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 for each one. If any zero is imaginary, its conjugate is automatically another one. Then rewrite each equation as a factor, or you get 0 on the right, and then multiply the factors together and simplify. So it says find a cubic function with the given zeros. So they're telling me that x equals 2, x equals -6, and x equals 6. What I said was write them back in factor form, in other words, get 0 back on this side. So -2 minus 2, I get x minus 2 equals 0. Add 6, I get x plus 6 equals 0. Minus 6, I get x minus 6 equals 0. So now, do you see that I have 1, 2, 3 factors when I started with 1, 2, 3 zeros. Okay, so now that I have the factors, x minus 2 times x plus 6 times x minus 6, set them to 0, multiply them back together, and I'll get the polynomial that I started with to get these solutions. So x times x is x squared, x times 6 is 6x, negative 2 times x is negative 2x, negative 2 times 6 is negative 12. Combine like terms, I get x squared plus 4x minus 12. But I have to multiply that by my third factor, which was x minus 6. And if I do that, I get x cubed minus 6x squared plus 4x squared minus 24x minus 12x plus 72 equals 0. Combine like terms. There's no other third degree. Drop it. I have a negative 6x squared, a positive 4x squared, which is negative 2x squared. I have a negative 24x and a negative 12x, which is going to be negative 36x. And a positive 72 equals 0. And my cubic function is x cubed minus 2x squared minus 36x plus 72. Okay, easy breezy. Okay, you try one, hit pause, come back when you're ready. Alright, and hopefully you got 2. If you did not, again, we're starting with our answers. X equals 6, x equals negative 4, x equals 7. We're going to change them into factors. Let me know if I bother you. This is going to be x minus 6. This is going to be x plus 4. This is going to be x minus 7. I'm just doing this in my head and skipping the whole writing them equal to 0. Then I start multiplying them together. X times x is x squared. X times 4 is 4x. Minus 6x minus 24. Combine like terms. X squared minus 2x minus 24. Times x minus 7 equals 0. X squared times x is x cubed. Minus 7x squared minus 2x squared plus 14x minus 24x plus, I should have brought my calculator, 28, 14, 168 equals 0. Alright, so now combine like terms, I get x cubed, negative 7x squared minus 2x squared is minus 9x squared. Positive 14x and negative 24x is negative 10x. And positive 168 comes down, equals 0. And then they just, instead of saying equals 0, said the function is. Okay? Alright, if you try this one, we are going to have, this says that x equals negative 2, x equals 1 plus the square root of 7, and x equals 1 minus the square root of 7. If I turn them back into factors, I'm going to have x plus 2 times x minus 1 minus the square root of 7 times x minus 1 plus the square root of 7. Again, skipping this. Add 2, x plus 2 equals 0. Minus 1 gives me x minus 1 equals the square root of 7 minus the square root of 7 gives me x minus 1 minus the square root of 7 equals 0. Same thing here. Minus 1, x minus 1 equals negative square root of 7. Add square root of 7, add square root of 7. I get x minus 1 plus the square root of 7 equals 0. Okay, now you can multiply in any order you want to. I'm going to multiply the two conjugates together because then I'll get rid of all those nasty i's. Or radicals, sorry. So I'm going to save this one for later. X times x would be x squared. X times negative 1 is negative x. X times the square root of 7 is positive x square roots of 7. Okay, then negative 1 goes. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Negative 1 times the square root of 7 is negative square root of 7. And then the square root of 7 goes. Negative square root of 7 times x is negative x square roots of 7. Negative square root of 7 times negative 1 is a positive square root of 7. And a negative square root of 7 times a positive square root of 7 is a negative square root of 49. So now if I clean this mess up, I don't have another second degree. If I look at my radicals, you see how I have a positive x squared to 7 and a negative x squared to 7? They cancel. If I have a negative square root of 7 and a positive square root of 7, they cancel. Okay? And then the radical that's left is going to be perfect. It has to be. The square root of 49 is 7. So I have x squared minus x is minus 2x. And a positive 1 and a minus 7 is negative 6. But I still need to multiply that by my x plus 2. So x times x squared is x cubed. X times negative 2x is negative 2x squared. X times negative 6 is negative 6x. Positive 2 times x squared is positive 2x squared. Positive 2 times negative 2x is negative 4x. Positive 2 times negative 6 is negative 12. Combine like terms. There's no other third degree. Negative 2x squared and positive 2x squared cancel. Negative 6x and negative 4x is negative 10x. Negative 12 drops equals 0. There's my cubic function. Okay? You try one. Pause and come back when you're ready. And hopefully you get number 3. If not, let's look at y. I'm going to have x plus 2 times x minus 1 minus the square root of 6 times x minus 1 plus the square root of 6. Again, you can multiply in any order you want, but I'm going to do my conjugates first to get rid of the radicals. So I have x times x is x squared. X times negative 1, negative 1x. Positive x square roots of 6. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Negative 1 times the square root of 6 is negative 1 square roots of 6. Finally, a negative square root of 6 times x is negative x square roots of 6. Negative square root of 6 times negative 1 is positive square root of 6. Negative square root of 6 times positive square root of 6 is negative square root of 36. And combine like terms. Cancel. I know that my radicals should all cancel. Positive x square root of 6, negative x square root of 6, gone. Negative 1 square root of 6, positive square root of 6, gone. Square root of 36 is a real 6. So I have x squared minus 1x minus x is minus 2x. Positive 1 minus 6 is negative 5. But don't forget I have to multiply that by this x plus 2, which gives me x cubed minus 2x squared minus 5x plus 2x squared minus 4x minus 10. Combine like terms, and I have my function is, there's no other cube, so x cubed, negative 2x squared, positive 2x squared, cancel. Negative 5x, negative 4x is negative 9x, and minus 10 drops. Okay? Alright, so what does the intermediate, well, we already talked about that. Alright, finding a regression equation for a set of data. You know this. You type your x's in L1, your y's in L2, stack, calculate to get the regression that you're asked for, and then use the values to write the regression equation. Alright, so you're going to go to Stat, Edit, type in all your stuff, and you're going to choose Cubic Regression. So my function would be y equals 0.25x cubed minus 1.25x squared minus 6.75x plus 19.75. You literally plug in your A, B, C, and D to what it tells you, and there's your function. Okay, so you try this one, hit pause, give it a shot, come back when you're ready, and hopefully you got 3. I put in my data and got the A, B, C, D that they did. Alright, this one now they want quartic regression, so be careful. Quartic, you're going to have to go down to, I think it's the one under cubic. Yeah, it goes cubic and then quartic. Alright, and again, then you'll get an A, B, C, D, and E. Plug in A, B, and they cut it off, but it's AX to the 4th, BX cubed, CX squared, DX to the 1st, plus E. Okay, and there's your equation. Alright, so how can you use the zeros of a function to write a polynomial function in standard form? Well, you write your zeros as factors, multiply the factors together, and then you have your function. Alright, and we are at homework, so happy homework, and I will see you next time.